In our previous video, we looked at how to multiply rational expressions. In this video, we're going to look at how to divide them. Well, it turns out that if you know how to multiply, you know how to divide. Because all we do differently when we divide is, well, first we change any division problem into a multiplication problem. And as you may recall from your days of dividing fractions back in elementary school, you change division to multiplication, you just make sure you multiply by the reciprocal, meaning you flip the second fraction around. So that's why I say if you know how to multiply, you know how to divide. It's the same thing as long as you remember to invert or to flip your fraction. Multiply and invert, multiply and take the reciprocal. So let's go ahead and factor first though. You can't cancel anything out until you have factors. So 7x is actually already factored. What I'd recommend you do is put a 7 and then times x to remind yourselves that those pieces can be canceled individually. You can cancel just the 7 or just the x. They're not super glued together with a plus or minus sign. Below that, we can factor this by using a greatest common factor, a GCF. Both of those terms have a 2 in common, so I'll divide out a 2, which leaves 2 and then x minus 5. I'll cross out what I had just factored. In the numerator on the other side, we have x squared minus 6x. Well, because I'm lazy and I don't feel like rewriting this, I'm going to factor, but where I'm going to factor that is below, because remember I'm flipping this around. So once again, I have a greatest common factor. They both can be divided by x. And then what's left behind is an x minus 6. So once again, I've written the top factored on the bottom because I know to flip this one around. If that confuses you, just rewrite that on the side with this flipped around. And then finally, I'm going to factor that trinomial, but I'm going to factor that up on the top. So two numbers that multiply to 30 but add up to negative 11 are going to be x minus 5 and x minus 6. And as I mentioned in the last video, if you need help with factoring, now would be a great time to go back and review one of those videos. So that's all I'm doing differently when I divide is just flip that second one around. Now's the fun part. Look for anything that's the same top and bottom anywhere and cancel them out. We can cancel out common factors, but we cannot cancel out common terms. So x minus 5 and x minus 5 can be canceled. I see an x minus 6 and an x minus 6. We'll cancel those out. And there's one more thing these have in common, and that's that single x. So I can cancel those out as well. If I look to see what's left over, the only thing left in the numerator is just a 7. The only thing left in the denominator is just a 2. So isn't that fun when you have this big, long, complicated math thing, but it simplifies to just something simple like 7 over 2. Let's take a look at one more example right here. Once again, I notice it's a division problem, and so I know to change this to a multiplication sign, I just have to flip that second fraction around. Well, normally, what I like to do is put whatever I have over 1, but I'm not going to do that this time. Instead, what I'm going to do is actually put it under 1. And the reason being is it has to do with this idea of taking a reciprocal. Normally, yes, that 1 would be underneath the 3x squared plus 5x. Part. However, since I knew I was going to end up flipping that, the 1 would end up on top. Again, if you don't like doing it that way, if that confuses you, then feel free to write it out in 2 steps. Okay? Let's go ahead and factor things out and see what happens. We cannot cancel anything until we factor first. So factoring this part right here, once again, I see I don't have a trinomial. It's not a difference of 2 squares, but there is a common factor in there. I'm going to pull out a GCF of just x, and what's left behind then is 3x plus 5. And then I'll cross out what I had just factored so I'm not confusing that. The 4x squared is already factored. You may want to put a times sign in between to remind yourself that those pieces can be canceled out individually. Or maybe you even want to do 4 times x to remember that that's actually what everything multiplied or factored out would become. Last up is this trinomial, the 6x squared plus x minus 15. Well, because there's not a 1 in front, and because there's no greatest common factor, I'm going to need to use the box method to factor this. Again, if you need a review of that, go back and watch a video for this. Just for time, I'm going to tell you what this factors into. This factors into 3x plus 5. Oops, there it goes. 3x plus 5. And then 2x minus 3. Again, if you want to see how that works, you can either ask me in class or go back and watch a box method factoring video. And then I'm going to cross out what I had just factored. So now's the fun part. We're looking for anything that's the same in the top and bottom in order to cancel them out. Well, right away I see that 3x plus 5 factor can be canceled out from the top and bottom. And Well, it turns out that that's it this time. There's nothing else that's the same in the top and bottom. Some people want to cancel these x's out, but take a look at where they're located. These are all from the denominator. So is this one. I'm not going to be able to cancel those out. So what's left in the numerator then, if I write my answer out, is just that 2x minus 3 piece. There is that times 1, but I don't really need that, so I'm going to ignore it. In the bottom, I've got 4 times x times another x. So altogether, I've got 4x to the third. It's really tempting. I see a lot of people tell me they want to cancel out the 2 and the 4. Remember, those are not factors. The 2x piece has a subtraction sign on it, so that's super glued in place. You cannot cancel anything out until it's been factored, and there's no 2 that we can factor out of that numerator. So there is my final answer.